Hello, welcome back. So let's round up our mechanical legend update. Why am I irritating you? Want to adjust the scale? I believe you know what I'm doing. It's just use of drawing and modification tool. In fact, modification use of modification tools mostly. If you've forgotten, then you have to revisit our AutoCAD core training, which is the module 1 of this training. Let's bring in our strainer. pumps, we can bring in the elevations as well. If you want to, there's no harm in doing that. Same for our jockey pump. So let's place the elevation beside the plan. This is the plan view of the main pumps. This is the plan view of the jockey pump. This is the elevation of the main pump, and this is the elevation for the jockey pump. So now you see the professionals on site will not be confused. They will just refer to this legend and know what is what. So what else are we missing? I believe that's all. We can take out the remaining vacant spaces. We don't need them. With this, I believe our mechanical legend is complete. Now we also have pipe schedules. For our water closet suite, the supply pipe is 13 millimeter. The drain pipe, like I said earlier, is a soil waste pipe you use for the WC, which is 100 millimeter. For the wash and basin, the supply pipe is 13 millimeter, while the drain pipe is 50 millimeter in diameter. For the bathtub, we did not make use of a bathtub, so let's take this out. We did not make use of a kitchen sink. This is a school, it does not have a kitchen, so let's take it out. We made use of a floor drain. Okay. Now this is a manhole and inspection chamber. For our manhole we used 700 by 700 in length and 700 in width. As for the depth, the site condition shall tell. That is why it's written varies at site. Now here are some points to take note of. All dimensions are in millimeter. Every fixture shall have its own isolating valve. So for instance, you can see this is this pipe is coming to this section of the building, and it also has a riser going up. So apart from this main isolation valve, each of these fixtures, that is the wash and basin, the WC, the toilet sprinkler, they all have their own isolating valve known as angle valve. So that is what that statement is saying. Apart from this general isolating valve, each of these fixtures have their own isolating valve. When you are carrying out maintenance on any of the fixture, you don't need to interrupt the other fixtures. So all drainage pipes shall be unplasticized polyvinyl chloride pipe, that is UPVC. All cold water supply pipes shall be PPR, not PPE. That is polypropylene random copolymer. Yes, it's a modern pipe that is being utilized now. It's very durable, flexible, good to use. So you can either use the PPR pipe or the UPVC, but I strongly recommend the PPR pipe. All inspection chambers and manholes shall flush with ground level, meaning they will not be high on the ground level. They should flush with the ground level to avoid obstruction. Kitchen hood ducts, we did not make use of kitchen hood, so we are taking this paragraph out. A borehole submersible pump, we are taking that as well out, because we did not compute for the submersible pump. We will leave that to the drilling company, borehole drilling company. Overhead tank capacity is 5,000 years. Distance between manholes shall not exceed 8 meters. Yes. So you can see for our foul water manhole, from this manhole to this manhole, the maximum should be 8 meters. It should not be more than 8 meters. That is what we are recommending. Though in some cases it can even be up to 10 meters, but I'm recommending 8 meters. So that is what that paragraph is saying. As for our stormwater, it's the same thing. The distance from this manhole to this manhole is 8 meters. It's not exceeding 8 meters. So that is the maximum I am recommending. You can recommend 10, but 8 is okay, I believe. So that's that for mechanical legend. Yes, and our mechanical legend is duly updated. Now, this brings us to the end of the module 2 of this training, which is the mechanical plumbing core training. I have some recommendations for us. Now, gain familiarity with the jurisdiction the proposed building is to be built in order to get the following data for accurate computation. And this data for soil percolation rate in order to design your soakaway pit accurately. Know the rainfall intensity for the jurisdiction in order to design your roof gutter and environment stormwater drainage system accurately. Know the outdoor temperature and solar irradiance in order to make accurate design and sizing of your AC system, air conditioning system, and ventilation system as well. Now, know the building and plumbing codes guiding the jurisdiction. You can make inquiries from the authorities regulating the jurisdiction, or you can ask your colleagues who you feel might know, might have an idea, or any other means of information you might come across. Also, know the materials and the schedules the architect is proposing for the building. For instance, remember when we came to size our AC system, we talked of the door material, the kind of door, the kind of glazing, the wall, the roof, the roofing material, in order to know the U factors, that is the coefficient of heat gain, in order to carry out your conduction heat gain for these components, for the doors, that is the building envelope. Also know the height of the building and height of doors and windows and walls as well. So that is what this paragraph is saying. Always be mindful and consistent with units when carrying out calculations. Very, very important, because this can change your value. Endeavor to specify suitable materials, components for the intended purpose. For instance, now, this is potable water supply. This water is supposed to be clean, to be neat, to be free from any debris or rust. So it won't be good for you to recommend a galvanized iron pipe for this potable water reticulation. Why? Because galvanized iron pipes are susceptible to corrosion and rust. If you use them over time, the zinc coating will wear off, and there will be rust in the pipe. Your water will be carrying rust in it. Water that is supposed to be clean will now be testing of rust. The water color will even change, and there will be heavy metal leaching in the water. So, plus galvanized iron pipes are heavy because they are metals, so they will add to the load of the building structure itself. They are not flexible, they are not easy to install, so you will incur high cost of labor to install them, along other disadvantages. So the best pipe to recommend is PVC pipe or PPR pipe, like we mentioned earlier. So that is an example of what this paragraph is stating, and they want to specify suitable materials. Now, carry out further research to keep up to date and remain relevant in the MEP profession. So do not rely on this training. Carry out further research to keep yourself abreast, in order to get the cutting edge information, the current trend, to go with the current trend. You can make this research. You can either go for additional training. You can interact with professionals. Many other means of getting first-hand information, current information, so that you will be relevant in the MEP profession. So one last thing, when an architect sends you a design, please look at the roof plan to see if there is provision for roof tank, so that there will be no need for you to design a stanchion. For instance, let me give you an example. So you can see this design, this roof plan has a provision for tank. So the water tanks, that is the overhead tanks, are placed on this roof, unlike in our own case, because our roof plan does not have provision for overhead tank. So we had to, let me show you, this is our roof plan. So you can see there is no provision for roof tank. That was why we had to bring in a stanchion stand, an elevated stanchion stand, in order to place our tank on. So that is that. Now we are going to move to the module 3, which is the final module of this training, which is the electrical design core training. We are done with the mechanical plumbing. That is the module 2 of this training. So see you in the module 3. Thank you for watching.